The topic is comparing unit rates to make decisions. The essential question is, how can you use unit rates to figure out things like what's a better deal, who is faster, etc. So you can use unit rates to help you make decisions and solve situational problems. So the first example right here says that Staples has a sale on pencils. They're selling a pack of 30 for $7.97 and a 12-pack of the exact same brand for $4.77. Which is the better deal? So when you're confronted with these type of problems, you got to set aside your personal preferences, because some of you might be like, well, I don't really need 30 pencils, so I think that this right here is the better deal. Or some of you might be like, well, 30 pencils, yeah, I need that many, so I'll get this one. So when you make your decisions and answer questions like which is the better deal, you can't base it on what your preference is. You need to base it strictly on the math in order to answer the question. So when it's asking you which is the better deal, you need to find the unit rate and make your decision based off the unit rate, okay? So what you want to do is to find the unit rate of each of the packs that they offer. So what I'm going to do is I'm going to use two different colors so that you can distinguish between them, and I would recommend doing that also so you don't get them switched around. And as always, I want you to make sure you label it, okay? So I have right here this 30 pack for $7.97, and you want to put the money on the top and make sure you label it. Okay, and then we have right here a 12 pack of those pencils, the same pencils, for $4.77. So again, you want to put the money on the top, label it, and the number of pencils on the bottom. Okay, so these two fractions right here, these are not the unit rate, because if it was the unit rate, they would have a 1 on the bottom, and you'll see that that's not a 1 and that's not a 1. So to find the unit rate, you want to have the denominator equal 1. Okay, that's how you know you found the unit rate. So to get the denominator to equal 1, 30 divided by what number gives you 1? Well, it'd be 30, because numbers divided by themselves equal 1. So 30 divided by 30 equals 1. So if you do that to the denominator, you must also do that to the numerator. Okay? So I'm going to go ahead and punch that in my calculator because I don't know that in my head. It is $7.97 divided by 30. And I do want you to write the divided by right here. Don't put it on this side because that wouldn't make any sense. Put it right here, because it's $7.97 divided by 30. Okay, and you're going to see that we have this pretty lengthy decimal right here, but I want you to think of this in the context of money, okay? So money, when you have money with the decimals, it's rounded to the nearest hundredth, okay, when you're given these decimals. So that's the tenths place, that's the hundredths place. So you're going to look behind it at that thousandths place to help you make a decision here. So if the number behind that 6, which is the thousandths place, is 5 or above, this 6 goes up by 1 digit. So since the number behind it is a 5, the 6 will turn into a 7. So this would be 0.27, which in money is 27 cents. Okay? So I want you to do your dollar sign and 0.27 to signify 27 cents per pencil. Okay, you should pause the video and try to find that unit rate of the second option here. Okay? And here's what it would be. And again, you're going to divide. You got to think to yourself, 12 divided by what number gives you 1? Well, it'd be 12. Do not divide by the same number here. No, okay? You divide by what this one is so that you get 1 over here for your unit rate. Okay, and $4.77 divided by 12. Okay, and you'll see right here, I want it to the nearest hundredth, and the number behind it is 5 or above. So that 9, well, the number after 9 is 10. So when you figure this out, instead of 39 cents, it would be 40 cents per pencil. Okay? Okay, now that you have found the unit rate, you can use the unit rate to help you decide which is the better buy. So think about this. Which is the better buy? Which is cheaper? Not your personal preference. Based on the numbers, tell me which one is cheaper, which one is the better buy. For one pencil, costs 27 cents or where one pencil costs 40 cents. Obviously, this option right here is the better buy. So I'm just going to go ahead and circle it. But you can't just do that. You can't just stop there and be the end of the problem because you want to answer the statement, which is the better deal. So this one, that 30 pack, this pack is the better deal or a better buy. And you know how by how much? By 13 cents. Don't forget this part, per pencil. Okay, the way I got that 13 cents is you can just go 40 cents minus 27 cents. And see 13-cent difference, but you got to include this per pencil part, okay? Because if you just said, oh, it's a better deal by 13 cents, when someone reads that, they're going to be like, no, that's not 13 cents, and they might get confused, okay? So you got to subtract your unit rates from each other to get that better deal per pencil or per whatever you're comparing, okay? So for your summary, I want you to answer this question, okay? Don't slack off. How does figuring out the unit rate help you decide which is a better buy? The next problem says, Antonio's produce stand sells 6 ears of corn for $1.50. Sergio's produce stand sells 13 ears of corn for $3.12. Which produce stand offers the better deal? So just a little background with the wording here. In case you don't know what an ear of corn is, that's just like corn on the cob, okay? And then produce is like a fruit and vegetable stand. All right, so to distinguish between the two produce stands, I'm just going to use different colors so that I don't get the math mixed up between the two produce stands. So I know Antonio's sells 6 ears of corn for $1.50. So I'm going to write all of his stuff in blue. Money would go on the top, and make sure you label it. So it's $1.50 for 6 ears of corn. Okay, and then the other person that owns a produce stand is Sergio. So Sergio sells 13 ears of corn for $3.12. And we're supposed to determine which produce stand offers the better deal. Again, it's not by your preference, like, oh, I think this guy is. You can't do that. You have to base everything off the math, okay? All right, so you know that this is not the unit rate because the denominator does not equal 1. If the denominator equaled 1, then yeah, that's the unit rate. But this is not, so we're going to have to go ahead and set up this proportion. So we want the denominator of every unit rate to equal 1. And this is the part where you have to decide 6 divided by what number equals 1? Well, it's divided by 6. $1.50 would also be divided by 6. And then 13 divided by what number gives you 1? Well, it'd be 13. Okay, and please do show all of this work, okay? So go ahead and figure out what $1.50 divided by 6 is. It is equal to 25 cents. And go ahead and figure out what $3.12 divided by 13 is. It gives you 24 cents. Okay, so right here, you can decide right now which one's the better deal, so go ahead and circle it. And you should have circled this one. And we got to write our sentence. Which produce stand offers the better deal? Whose stand was this? It was Sergio's. Sergio's produce stand has the better deal or better buy by how much? Well, 25 cents minus 24 cents is 1 cent. And this is what 1 cent looks like. Don't put 0.1, that's 10 cents, okay? 0.01. That right there is 1 cent. And don't forget this is the last part, per ear of corn. Okay? All right, number 3. During their last workout, Taylor ran 2 1/4 miles in 15 minutes. And then Jasmine ran 3 3/4 miles in 25 minutes. Who was the faster runner? Okay, who was the faster runner? So something I want to show you here is, well, the first one I'm going to write in blue for Taylor, 2 1/4. So when you see this right here, there's a couple ways that you can do this. You can keep it a fraction when you put it into your fraction, but that would kind of look a little bit confusing to me. So one way you can do this is like this. You know that the whole number is 2, so you can know it's 2 and something. Well, then you go 1 divided by 4. One divided by 4 equals 0.25. So it's 2.25, 2 and 25 hundredths. Another way you can do this to figure out the decimal is like this. 4 times 2 is 8. 8 plus 1 is 9. Keep the same denominator. Okay? So these are equal right here. And then you know that this means divide. So you would go 9 divided by 4. Same thing. Okay? Same thing. All right? So instead of writing this right here, I'm going to write the fraction. Okay? And distance and cost go on the top. Time is always on the bottom, typically. So this would go on the top and label it. And that was in 15 minutes. And then the other one, same thing right here, 3 3/4. I know that that's a 3. 3 divided by 4. 3 divided by 4 equals 75 hundredths. No, not 75. Or you can go like this. 4 times 3 is 12. 12 plus 3, 12, 13, 14, 15 is 15 fourths, which gives you 15 divided by 4. Same thing. Okay, so this one would be 3 and 75 hundredths miles in 25 minutes. Okay, let's go ahead and figure out the unit rate. So this is not the unit rate yet because the 1 is not on the bottom. We want 1 on the bottom, and that's when you know you found the unit rate. Okay, so 15 divided by what number is 1? Well, it's 15. So 2 and 25 hundredths divided by 15. Go ahead, type that in, and you get that. Oops. Miles. So, what's her name? Taylor went 15 hundredths of a mile in 1 minute. It's 1 minute, not 1 minutes. Okay, and right here we're going to have to go 25 divided by 25, and then 3 and 75 hundredths divided by 25 to get our unit rate. 3 and 75 hundredths divided by 25 is 15 hundredths miles. Okay, so right now go ahead and make a determination to decide which one was the faster runner. Okay, so when you see that they're the same, the unit rates are the same, you basically have both answers. And so you're right, they're going at the same rate, so neither is faster. Okay. Here's your summary. How do you know when you found the unit rate? Answer that question, please. Number 4 says, a blue car travels 18 2/5 miles using 8/10 gallons of gas. A red car travels 17 2/5 miles using 75 hundredths gallons of gas. Which car can travel farther on 1 gallon of gas? So for this problem, I'm just going to use two different colors so I can distinguish between the two. And luckily I have a blue pen and a red pen. And I'm going to use the blue pen to represent that blue car. And you'll see that we have a mixed number right here, 18 2/5. Well, you can go ahead and keep it like that if you want, but when I'm finding unit rate, I just find that easier when I convert the fractions, any fractions I have, into decimals. Okay, so I'm going to go ahead and show you how to convert that 18 2/5 into a decimal using two methods. So I'm going to write it over here so you can see it, so I have more room. 18 2/5 is how it is right now. And to turn it into a decimal, I know that 18 is the whole number, so I'm going to write just the big old 18 right there, because that's the whole number, and I'm going to put a decimal right there. Now I need to figure out what 2/5 is in its decimal form. And something that you should hopefully remember is this, you just go 2 divided by 5. And you can use your calculator if you have one. 2 divided by 5, that is 4/10. So I know that this decimal equivalent of this fraction is 18 4/10. Another way you can figure out this problem, or figure out how to convert from a fraction to a decimal, is starting off with that mixed number. You can convert this mixed number into an improper fraction first, and then from there go to a decimal. So here's what I mean by that. To turn a mixed number into an improper fraction, you would go 5 times 18, 5 times 18, and that's 90. Then you would add the 2. Well, 90 plus 2 is 92, and you'd keep the same denominator, okay? So this mixed number and this this improper fraction and this mixed number are equivalent. So if I wanted to, instead of writing this mixed number in my problem, I can totally write this improper fraction, because they're interchangeable, because they're equal. Now to go from an improper fraction to a decimal, you would just go 92 divided by 5. And look, you get the exact same decimal as you did in the first method I showed you, okay? All right. So that blue car travels 18 4/10, which is equivalent to 18 2/5 miles using 8/10 gallons of gas. And I'm going to go ahead and write down this rate right now, okay, for the blue car. So I want the distance in the numerator. I'm going to write that as a decimal, and I'm going to label it. And the denominator would be 8/10 gallons. Okay, 8/10 of a gallon. That right there is the rate. Now I'm going to go ahead and find the rate for the red car. So the red car travels 17 2/5 miles on 75 hundredths gallons of gas. And you'll see again we've got a mixed number right here. So I'm going to again show you how to convert that mixed number into a decimal. So you know that the whole number is 17. And then we just have to figure out what 2/5 is as a decimal. And you might already remember it from the previous mixed number, but I'm going to show you again. It's 2 divided by 5. Numerator divided by denominator to get its decimal. And then you'll see it's 4/10. So this equivalent decimal to this mixed number is 17 4/10. Or the other way you can do it is taking your mixed number and going 5 times 17 plus 2. 5 times 17 is 85 plus 2. You get 87. So the improper fraction is 87/5. And from there, when you have your improper fraction, you can turn it into a decimal by going 87 divided by 5. 87 divided by 5 equals 17 4/10. Okay, so for that red car, I'm going to go ahead and write 17 4/10 miles on 75 hundredths gallons of gas. And that also is a rate. All right, now let's go ahead and find the unit rate. And for a unit rate, you want to set up your proportion, your equivalent fraction. And for the unit rate, you want 1 in the denominator. And same thing over here for this red car. Okay, so you got to think, how did we go from 8/10 to 1? You had to divide by 8/10. And if that's not very straightforward to you, you can double check it. 8/10 divided by 8/10 is 1. Any number divided by itself would give you 1. Okay, there you go. So I would have to do that to the numerator. 18 4/10 divided by, please make sure you put your decimal there, otherwise you will get it incorrect. Okay, 18 4/10 divided by 8/10, you would get 23. And make sure you label it. All right, for the next, for the red car, you need to figure out 75, how do I get from 75 hundredths to 1? Well, we just divided by 75 hundredths. 17 4/10 divided by 75 hundredths, that will give you 23 2/10 miles. Okay, so before you you go, oh well, oh gosh, this one's the better deal because it's cheaper. You got to really read the problem, okay, the question. It says, which car can travel farther on 1 gallon of gas? So the blue car can go 23 miles on 1 gallon, but the red car can go 23 2/10 of a mile on 1 gallon of gas. So therefore, the car that can travel farther on 1 gallon of gas is that red car right there, okay? So let's go ahead and write our sentence right here. The red car can go, well, how much farther? 23 2/10 minus 23 is 2/10. 2/10 miles farther on 1 gallon of gas. Okay? All right, number 5. Which is the better buy? You can get 4 7/10 pounds of turkey for $12.89, or 23 5/10 pounds of turkey for $64.45. Now again, don't let your personal opinion help you answer this. Don't be like, well, gosh, who needs that much turkey? We need this one. Don't do that. You got to base it all on the math, okay? So what we'll do here, money on the top. So $12.89 for 4 7/10 pounds. Abbreviation for pounds is LBS for more than 1. And I know to find the unit rate, I need the denominator to equal 1 pound. And for this guy over here, it's $64.45 for 23 5/10 pounds. And we want the denominator to equal 1 pound. Okay, now let's go ahead and unit rate it. Figure it out. 4 7/10 divided by what number is 1 pound? Well, it's 4 7/10. So we do that same thing to the numerator. So you would get 12. Okay, look at this decimal. Round it to the nearest hundredth. It's money, okay? So you look at that thousandths place because it's behind the hundredths place, or to the right of the hundredths place. So 2.74, well, if the number behind the 4 is 5 or above, that 4 turns into a 5. But since the number is 2, that 4 stays the same. So 2.74, $2.74 per pound. Okay, and you're going to do the same type of thing to the other side. You're going to divide by 23 5/10. Because you want that denominator to equal 1. Don't forget your decimal though, okay? And please type it in your calculator correctly so you don't make a mistake like I can do sometimes. Alright, again, I got another decimal. Okay, round it like money. So 2.74, because the number in the thousandths place is not 5 or above, so that 4 stays the same. Don't forget to label. Okay, so to answer this question, they cost the same per pound, so it's the same deal. Don't forget the per pound. Same deal. Okay, to answer the summary, you need to describe and provide an example of how to round a decimal to the nearest hundredth. Okay, so you do have to provide an example, and it's kind of neat that we just had an example right up here that you could use if you want, or you could be creative. So describe and provide an example of how to round a decimal. When you have a decimal, how do you round it to the nearest hundredth place? Okay? 3 chefs competed in a cookie baking competition. The table below shows their results. So we have the chef named Flourcoin, and she baked 180 cookies in 60 minutes. Vanessa baked 360 cookies in 120 minutes. Caesar baked 100 cookies in 40 minutes. So which chef baked the fastest? So your first idea might be like, well, this guy baked the fastest because it only took him 40 minutes. But this is one of those cases where you need to find the unit rate so you know how many cookies were baked in 1 minute, okay? So since there are 3 people we're comparing, I'm going to use 3 different colors. So I'll write Flourcoin's information in this green color, and I'm going to go ahead and start there. So I know that time needs to go in the denominator, so I'm going to put the 60 on the bottom and this 180 on the top, and be sure to label it, okay? So it's 180 cookies in 60 minutes, okay? And you also got to make sure that each of the units are the same. These are all in minutes. But please don't be like, oh, I'm going to convert this to 1 hour and do these as minutes. That's going to be confusing. Keep it all the same, okay? So it's minutes, minutes, minutes. Don't do hours, minutes, minutes. Don't do that. Or don't do hours, hours, minutes. Don't do that. Keep it all the same and consistent, okay? All right, so for her unit rate, I need to divide by 60. Divide by 60. And when you do that, you end up with 3 cookies per minute. Okay, so Flourcoin can bake 3 cookies in 1 minute. That's pretty impressive. All right, so for Vanessa, I'm going to write her information in blue so I don't get confused. And she bakes 360 cookies in 120 minutes. So to find her unit rate, we need to divide the numerator and the denominator by 120. And 360 divided by 120 is 3 cookies. So what do you know so far? These 2, Flourcoin and Vanessa, are baking cookies at the same rate, 3 cookies per minute. Well, let's go ahead and check out Caesar's. And Caesar can bake 100 cookies in 40 minutes. So to find his unit rate, we need to divide the numerator and denominator by 40. So 100 divided by 40 is 2 5/10. Okay? So to answer the question, you need to answer the question, which chef baked the fastest? So this is different than those problems where they're like, hey, which one's the better deal? You know, when it's a better deal, you want to go with the cheaper one. But this one, it's not a better deal thing. It's who's the fastest. So you got to analyze this. She can make 3 cookies in 1 minute. So 1 minute passed by, she's already made 3 cookies. 1 minute passed by, she's made 3 cookies. 1 minute passed by, he's only made 2.5. So therefore, the fastest are Flourcoin and Vanessa. Okay? So Flourcoin and Vanessa were tied. They can each bake, 3 minus 2.5 is 0.5, which is 1/2. They each can bake 0.5 or, 1/2. Those are interchangeable because they're equivalent. A cookie more than Caesar per minute, or you could say in 1 minute. Okay? All right, for your summary, and please answer this, why should you always label your rates and unit rates? So why is it important to label? Label, label, label. Okay, so these are other names for unit rate. And I'm going to show you these just because your book and assessments they might not say the word unit rate, and I still want you to know, what they're talking about. So here's a fancy thing they'll use. Instead of saying unit rate, they're going to say something called constant of proportionality. Constant of proportionality. If I could spell it. There we go. Okay, so if they say find the unit rate, you can say, oh, find the constant proportionality. They're interchangeable, okay? They've also used the word constant ratio. So if they tell you to find the constant ratio, that means just find the unit rate, okay? Scale factor is another word that means unit rate, and it's typically more used in geometry settings, but scale factor is the unit rate, okay? Your math assessments, they might say find the unit rate, and they use the word R, or the letter R right after it. So sometimes they'll use that. Your math book, sometimes we'll say find the unit rate K. I don't know how they came up with K, but that could mean unit rate in your math book. Okay, and another thing that means unit rate is Y divided by X. Okay, your dependent variable divided by your independent variable. All right, so all those mean unit rate. So instead of saying unit rate, you can use any of these above, okay? So answer answer the summary. What's a word that you're going to use instead of saying unit rate? Which one would you use? Okay, bye.